I'm Anil Kumar, and here is another very interesting question shared by my subscriber. Let me first thank this excellent group which I have. They're so active and they keep me on the toes. Now, my friend, you wanted to have an example where we're talking about double rational inequality. So I'm just using your example. Here it is. So you said, find the solution of this rational inequality, which is 2x minus 3 is less than x over x minus 2, which is less than 3. And we need to find the solution of this inequality. Now, we can actually solve such questions in two different ways. Well, every question can be solved in many different ways, but I prefer to show you the graphical representation of the same, and then we'll discuss how to solve it algebraically. Correct? So what I will do here is sketch the rational function, which is x over x minus 2. So x over x minus 2 means that we have a vertical asymptote at 2. So let's say this is the vertical asymptote. Okay, so this is the vertical asymptote. As you know, most of my diagrams will be kind of rough sketches, but good enough to understand the concept. So that's the whole idea, right? So this is the vertical asymptote, and we are saying this is at x equals to 2. We're trying to represent the rational function here. Okay. Now the horizontal asymptote here is these two coefficients ratio, because their degree is same, will be at 1. So let me sketch this at 1. So let's say this is at 1. Okay, so this is my horizontal asymptote, and I'm saying that this is at y equals to 1. Now to see which side is this rational function, it is basically reciprocal function transformed, right? So which we can very easily get. If I add 1, correct, then I'll have a rational function here. Okay, now let's see how. If I substitute 0 here, so 0 over something, we get the point 0. So 0 is on the graph, correct? So 0 is on this side. So what I'm doing here is, this is not an exercise on sketching rational functions, right? So what I will do is, at this stage, kind of sketch the function just with 1 point, and that 1 point for me is good enough. So one part will be on this side. I know the other part is on the other side, and we know this is the horizontal asymptote. So my graph will be kind of like this. Is it okay? Now these quick sketches are very important to check the answer, at least if you're not solving like this, right? And then these functions do have a symmetry. We'll have a graph like this, right? So that is how we'll have a graph. You can always take a value 3, for example. So if I take 3 here, then I get 3 over 3 minus 1. So I get 3. So if I take 3, that is, let us say this point, 3, then it will be kind of there, right? So this point is at 3 for us. Okay. So that helps to kind of sketch the graph. Well, so we got the function here, which I'm representing. So we have function x over x minus 2 on the graph. Now, let me sketch the other two linear functions, which is, let's say this 3, right? The upper boundary for us. So y equals to 3 is the function, which happens to be a straight line. Is it okay? So, I mean, it should go through 3. Okay, so this is 3 for us. So this is the line which is y equals to 3. A horizontal line. We're looking for everything which is less than 3. That means on the right side of this. So that becomes part of our solution. Is that okay? The other part is this straight line 2x minus 3. Okay, so let me get another ink to represent 2x minus 3. Okay, so let's use the red one. Okay, that's fine. 2x minus 3 means that we have a y-intercept of minus 3, right? And the slope is 2. So if let's find okay, so this is the one. So slope is 2. So for what value will I have an x-intercept? So 2x minus 3, so y is 0 for x equals to 3 over 2. That means 1.5, correct? So it is like kind of going from here, right? So it's kind of going from here. And let me also see, this seems to be a critical point for me, which is at x equals to 3. If I put 3 here for this line, then it gets 6 minus 3. It happens to be the same point. Do you get the point? So this is a very, very good example where somehow the calculations are easy and we can really appreciate the concept. So this is the line which represents y equals to 2x minus 3, correct? So we have got all the three functions here. We have the rational function x over x minus 2 and the two linear functions y equals to 3 and y equals to 2x minus 3. Now, what are we looking for? If I see from this point of view, right hand side, the rational function less than 3 means that we are looking for either, so let me just draw the solution here. So what are we looking for? So this portion, right, this portion is good enough, right? So this portion is good. Here we see that the rational function is less than 3. Is that okay? And the other portion is on the side, which is on the left side of 2, right? So which is less than 3. So let me shade that also. So we have this also good enough portion as a solution possible. Is that okay? So this solution is because of this part of our inequality, correct? And of course 3 is not included since we have less than. Perfect. Now how about the other part, which is we are saying that the value of this rational function should be greater than 2x minus 3. So value greater than 2x minus 3 is where? It is either on that side, but that side is not good enough for the first one. So, so it is this portion, okay, where rational function is greater than this red line, which represents 2x minus 3. And the other one is wherever you have this point of intersection, right? So wherever you have this point of intersection, so beyond this portion, so that is where we have the solution. Do you see? So the common solution is within this interval. Do you get it? So basically, if I find the intersection or a point where these two are equal, so once I get this particular point where both the graphs are intersecting, I will know left side of that is my solution, right? So a quick solution, if you have a multiple choice question, something like this, could be found by just equating 2x minus 3 equal to x over x minus 2. So we are just trying to find this point of intersection. So we can cross multiply and find the solution, correct? So we'll get this point of intersection. So you can always get it, okay. Now, how to solve inequality? That is the question. Since we are going to do this part in detail, so I'm not getting in at present, okay. But I've given you the concept and you right there have a solution also, okay. So where are they equal? So it's not very difficult to find. If I substitute x equals to 1, we know that is the solution, kind of, right? So 1, we get minus 1 here, and approximately from the graph I could see it may be rough sketch, but it gives you a fairly good idea. 2 times 1 minus 3 is minus 1. So this point seems to be 1, right? So when you solve this, you will get the solution, and the solution will be that x is less than 1, correct? So that is the only solution for the given double inequality. So we found it quickly with the help of a sketch, but now we'll follow a method. The method here is that we need to solve two inequalities now simultaneously because it's a double inequality, and somehow we cannot multiply by x minus 2 since x minus 2 could be negative or positive. If it is negative, I have to interchange these inequalities, and I don't know when to interchange. So that's not possible. So we'll solve two inequalities. Okay, so that is the concept. Two inequalities and common solution. That means with AND condition. Is that okay? Will be the part of solution for us. Like you saw here, solution for 3 was on the right side of this and on the left side of that, correct? So of 2, right? So that was the solution for the first, the right side, and then for the other one the solution was on the left side of this, and that one is a common solution, so that becomes the solution. So what we are going to do is we are going to solve two inequalities. So first one is 2x minus 3 less than x over x minus 2. So let's solve this. So to solve such inequalities, we have to bring it over to the left side. So minus x over x minus 2 less than 0. Then we can take a common denominator, which is x minus 2. Multiply this 2x minus 3 by x minus 2 minus x, is that okay? Less than 0, and then expand it. So 2x squared minus 4x multiplied by minus 3x plus 6 minus x divided by x minus 2 should be less than 0. And then we can combine the like terms. We have 2x squared minus 4x minus 3x is minus 7x, and minus this is minus 8x plus 6 divided by x minus 2 is less than 0, and I think that's the space I have. So I'll move on to the right side, add one more column as I normally do. Let's factor the numerator. Okay, so 2 is common, so we get x squared minus 4x plus 3 divided by x minus 2 is less than 0, right? So clearly we do have a restriction, x cannot be 2, right? Okay, so let's further factor this. Product 3 sum minus 4, so it is x minus 3 times x minus 1. Really beautiful question, right? So we are not involved with decimal values and difficult calculations. We are only involved with the concept, and that's what I love about this question. Excellent. So we have to solve this inequality, right? So we have kind of 3 zeros, 2 from the numerator, 1 from the denominator. So that is a vertical asymptote as we saw here. Let's analyze this part. Okay, should I do it here itself? Okay, let me do it here. So what we have here is kind of 3 zeros. Okay, so we are looking to analyze factors which are x minus 3, x minus 1, x minus 2, and we realize that we have zeros at 1, 2, and 3. So this is 0, another 0, another 0, right? So the zeros for the denominator will be vertical asymptote, so I represent normally as a whole, correct? So this 0 is at x equals to 1, this is at x equals to 2 and 3, and the factors which we have will include 2 times x minus 3, for example, here, and then we can have x minus 2 and then x minus 1. So I just put them in order. Okay, let us take the test points on the left side. Between minus infinity to 1, we'll take test point as 0. Here we could take 1.5, 2.5, and let's say 4. Now for these test points, the first factor, if I write 0, will be negative, this will be negative, this will be negative, and this is going to be positive in this interval, which is from 3 to infinity. For minus 2, this will be negative, negative, positive, positive. For this, it will be 0 will be negative, but 1.5 will make it positive. Is that okay? So all three, when you take together, then what do you get? Well, in this case, what you get is 3 negatives means a negative, 2 negatives means a positive, negative and positive, correct? So the possible solutions are between, so for this inequality which we solve, so possible solution is, let me represent this on a number line. It is kind of simpler. So on a number line, what we saw here is, let us say this is 0. So one possible solution, because less than 0 means we are looking for negative, right? So these are the possible solutions. Is that okay? So not including, because this is not including. So one possible solution is from 1 to negative infinity, and the other one is between 2 and 3, right? So between 2 and 3. So the other one is between 2 and 3. Is it okay? So between 2 and 3. So that is the possible solution from the left side inequality, correct? So now let us solve the right side, which is for us, so we are solving the next inequality, which is x over x minus 2 less than 3. So we'll bring 3 this side, so we'll have x over x minus 2 minus 3 less than 0, and then we'll take the common denominator, which is x minus 2, and we have x minus 3 times x minus 2 is less than 0. Okay, again running out of space, so we'll just move forward on the right side. Good. So let's continue with this. So what we have here is x minus 3x, and that gives me plus 6 divided by x minus 2 less than 0, and here x minus 3x is minus 2x, right? So we have minus 2x plus 6 over x minus 2 less than 0, and then we can take minus 2 common, right? We can take minus 2 common. So what we get here is minus 2 common. So minus 2, and we have x minus 3 less than 0, x minus 2. Is that okay? So that is what we get. Solving this inequality, we have now two zeros, one at x equals to 3, the other one is at x equals to 2, correct? So these are the two zeros to check for this inequality. Now, if you substitute this value, then when is this inequality true? So this is 0 at x equals to 3 we found. If I at x equals to 3, it is 0. Since we ran out of space, what we will do is, we'll not continue with this, but you can do similar calculations as we did here. And the solution which you will get on this side, let me represent here on a number line. So we're representing the right side solution now, kind of here on the number line. So when you analyze this rational function, we will get a solution which says that it could be, let's say this is 2 for us, this is 3 for us, and this is 0 for us. So if I substitute a value which is more than 3, then this is negative. Do you see that? So it is negative, so it's less than 0, correct? So that means more than 3 works for this area. This is the solution. Is it okay? More than 3. And if I take a value which is less than 2, there are 2 zeros only, right? So we are testing 2 values on either side. So if I take a point less than 2, then also